also, I have taken sigma x like this. This is the length. So along the length, whatever stress is there, let me take the stress in this direction as sigma x, stress in this direction as sigma y, stress in this direction as sigma z. So you have got length along x direction, diameters along y and z directions. Okay. So now what is the initial volume? Initial volume in this case is area multiplied by length. So area is pi d square by 4, length is L. So that is the initial volume. Final volume is V plus delta V. So due to this tensile stress that is going to develop or tensile force that is acting on the cylindrical bar, there will be increase in the volume. So that's why we have taken V plus delta V. So what happens due to that elongation, due to that tensile stress, what happens? There will be change in length. So L becomes L plus delta L. Diameter becomes D plus delta D. So both will change. Length also will change. Diameter also will change. So in the place of D, we have to take D plus delta D. In the place of L, we have to take L plus delta L. In the place of V, it becomes V plus delta V. Now, what is the change in volume? This minus this. So final volume minus initial volume is the change in volume. Just subtract this from this. So I have shown here all the steps. So once again, if you simplify this and if you neglect the smaller terms means, suppose if we have delta D square term, delta L square term, so those things can be neglected. So product of two smaller quantities is still smaller, and that term can be neglected. Using that concept, see here, what are the terms there that are neglected is this minus this. If you do, you are going to get this term, this full term after multiplication and simplifying. So here you can neglect this delta D square term, delta D into delta L term. So these two terms you can neglect. And if you add the remaining terms, you will be getting this. See here, you will be getting this term. So this is your delta V. So you have to work out this. So after neglecting the smaller terms, this is what you will get for delta V. Now, what is volumetric strain? According to the definition of volumetric strain, it is a ratio of change in volume to initial volume. So change in volume is delta V. So that is this expression, the numerator, divided by initial volume is this. So if you simplify that once again, and if you write it in standard form, you'll be getting like this. See, in the case of cylindrical bar, see, the volumetric strain will be equal to 2 times the diametrical strain plus 1 time linear strain. See, diametrical strain is delta D by D. Linear strain is along the length. Linear strain is delta L by L. So what you can write here, in the case of cylindrical rod, the volumetric strain is equal to linear strain plus 2 times diametrical strain. So they can ask a derivation for the simple derivation for 4 or 5 marks. They can ask this question. So you have to remember this formula if they give a problem. So for rectangular rod, volumetric strain is this, Ex plus Ey plus Ez. For cylindrical rod, it is this, because only diameter will be there. Yeah, next, in the case of a sphere. So sphere, what happens? Very simple. So in the case of a sphere, initial volume formula for spherical this thing is, sphere is 4 by 3 pi r cube. If r is the radius of that sphere, 4 by 3 pi r cube, it is the formula for volume of a sphere, or pi d cube by 6. In terms of diameter, it is pi d cube by 6. Okay, if you put r is equal to d by 2, diameter divided by 2, radius is equal to diameter divided by 2, so you will get pi d cube by 6. So in this case, if you want the change in volume, the simple method is differentiate both sides. So delta V. So delta V is equal to pi by 6 into differentiation of d cube will be 3d square into delta D. So this is called as the total differential in mathematics. So now if you want that is volumetric strain in a sphere, delta V by V. So delta V is this, V is this. This is V. This is delta V. This is V. If you simplify that, you will get a simple expression 3 times the diametrical strain. Because in the case of a sphere, in all the 3 directions you have diameter. X direction also is diameter, Y also it is diameter, Z also it is diameter. So whereas in the case of cylindrical rod, along the length it is linear strain, along the Y and Z directions it is diameter. That is why it is 2 times the diameter. So one is along this y direction, another is along z direction. This is the strain along x direction. Whereas in the case of rectangular bar, strains in all the three directions we have to find out using generalized Hooke's law and we have to add. So this is how we are going to find the volumetric strains for three types of objects. One is rectangular rod, another one is cylindrical rod, third one is sphere. So these are the simple book ones. Now, very important, we are going to do problems on this. So I explained about generalized Hooke's law yesterday. Now we will see how we can solve the problems. One problem we have to clearly understand. Then you can do any number of problems. So in the first problem here, a block of steel is subjected to forces as shown in the figure. So forces are given here. See, this is the steel block. It is made of steel. So he has given this is my x direction, this is y direction, this is z direction. So fix that. X is this horizontal, y is vertical, z is along the width. Now 200 kilonewton is he has given in the x direction. So that means this is the force in x direction, compressive force. It is a compressive force. See, towards the block he has given the arrow. In y direction he has given 100 kilonewton tensile force. It is away from the block. In z direction also it is tensile. It is he has given away from the block. So on the dimensions are 500 mm by 200 mm by 100 mm. So 500 mm is the length, 200 mm is the width, 100 mm is the depth. So this is what is the given problem. The question is find the change in volume of the block. Take E is equal to 2 into 10 power 5 MPa. Even if it is not given for steel, you can assume that value 2 into 10 power 5 Newton per mm square or MPa megapascal. Poisson's ratio 0.25. Okay, Poisson's ratio for the steel is 0.25. So this is what the problem is. He has given the diagram and this is the question he has asked. So first step is to find the stresses in all the three directions. So how to find stress? Stress is given by whatever force is acting in that direction divided by the area over which it is acting. So area over which it is acting. Now let us say sigma x. Sigma x is the stress in the x direction. So stress in force in the x direction is compressive force. So force is 200 kilonewton. So force divided by area is stress. So 200 into 10 cube. Why it is 10 cube? We are converting kilonewton to Newton. So 200 into 10 cube divided by area. This area we have to take. We should be very careful. Area normal to the force. Area normal to the force is this area. So this area is 200 into 100. So that's what I have taken here, millimeter square. So you will be getting 10 Newton per millimeter square. Brackets I have written compressive because it's a compressive force. Sigma x is compressive here. Next, sigma y. Sigma y is the stress in the y direction. So force in the y direction is 100 kilonewton. So it is tensile force. So 100 into 10 cube divided by area over which that 100 kilonewton is acting is this area. Length multiplied by width. So this is 500 by 200. So that's what I have taken. 500 into 200. So you are going to get 1 Newton per mm square. Bracket I have written tensile. It is a tensile force. Therefore, tensile stress will develop. Next, third one is sigma z in this direction. Sigma z. 50 kilonewton is given. So he has given 50 kilonewton. So 50 into 10 cube in newtons divided by this is acting over this area. See here, this area. 100 into 500 into 100. So front and back face. That is your z direction perpendicular. So 500 into 100. So there is also you are getting 1 Newton per mm square. It is also tensile. By seeing the arrow, you can say that it is tensile. So you have calculated the three stresses by dividing the forces in those directions by the respective areas. Areas are normal areas, cross-sectional areas. Okay. Now in x direction it is compressive, 10 Newton per mm square, sigma x value. Sigma y value is 1 Newton per mm square tensile. Sigma z is 1 Newton per mm square tensile. So this is the first step. So sometimes they will give force and the dimensions they will give. So once they give force and dimensions, you can just calculate the stresses. Suppose if they give stress values directly, you need not do this step. Directly sigma x, sigma y, sigma z you will be knowing. Now next step, second step, we have to calculate the strains. This is stress values. Strain values you have to calculate. Strains are obtained by using that generalized Hooke's law. That's what I told yesterday. So generalized Hooke's law, you should be very careful, understand this problem. Now, first I will calculate the strain in x direction, which I call it as Ex. Ex is the strain in x direction due to all the three stresses. Now, first I will take one by one. In the first, this is sigma x. So sigma x is compressive here. So I told compressive should be taken as negative. So what happens here? Minus sigma x by E. So minus sigma stress divided by Young's modulus. So minus sigma x by E is the strain in x direction. X direction due to sigma x. Next, strain in x direction due to sigma y. Due to sigma y. That we have to calculate. So now that is superposition, principle of superposition. We know that sigma y is tensile. See here, it is very important. Sigma y is tensile. So it is tensile in y direction. So therefore its effect in x direction is compressive. So therefore I have taken negative. See, minus. So sigma y is tensile in y direction. Hence it is compressive in x direction. So elongation will take place in this direction. Contraction will take place in x and z direction. That is the meaning. So minus sign shows that it is compressive in x direction. Mu will come because it is lateral strain. Mu term will come into sigma y by E we have to take. Sigma y by E. Next, third one, what is the strain in x direction? Third term, what is the strain in x direction due to sigma z? So once again, sigma z is tensile. Tensile in z direction, but it is compressive in x direction. So we are calculating Ex means strain in x direction. So once again, since it is tensile in z direction, it becomes compressive in x direction. So minus will come here also. So minus mu times sigma z by E. So that means the first one is longitudinal strain or linear strain. Second and third terms are lateral strains or transverse strains. So when you are writing the second and third term, you should be careful. In that direction, if it is positive, in the other two directions it will be negative. So keep that in mind. That is the meaning. Now, once you write this, next step is just go on substituting the values. So minus I can take common here, minus 1 by E into sigma x plus mu times sigma y plus sigma z. So minus 1 by E is 2 into 10 power 5. He has given the value of Young's modulus in Newton per mm square. All the values you have to keep it in Newton and mm square only because stresses will be in Newton and mm square. Length will be in millimeters. Forces, even if they are given in kilonewton, you have to convert that into Newton and substitute. So sigma x we have calculated, it is 10 plus mu is given as 0.25 into 1 plus 1. Here you need not worry about the sign because sign has been considered here only. Only numerical values you have to take. Whether it is tensile or compressive, it is immaterial. We have taken that account here. Minus represents compression, plus represents tension. Now, .25 into 10 power minus 5 is the strain in x direction due to all the stresses, sigma x, sigma y, and sigma z. That is the meaning. Next, we will calculate Ey. What is Ey? So Ey is the strain in the y direction due to all the three stresses, sigma x, sigma y, sigma z. So here you see, first I will write what is the strain in y direction due to sigma y is tensile. Tensile means it is positive. Therefore, I have taken positive. First, I have written sigma y term. Then, I will due to sigma x. Sigma x is compression. Since it is compression in x direction, it will be tension in y direction. So, I have to take plus sign. Mu will be there into sigma x by E term will come. Next, due to sigma z. Sigma z is tensile in z direction. Therefore, it should be compressive in y direction, opposite nature. So, minus term will come. Mu into sigma z by E. So here also you just substitute the values and simplify. You will get Ey is equal to 1.625 into 10 power minus 5. No units for that. Next Ez. So strain in z direction due to all the three. So once again sigma z due in z direction sigma z is tensile. tensile is positive in that the particular direction, so it is positive. So sigma z by E will come. This is the linear strain. Lateral strains due to sigma x. Sigma x is compression in x direction. Therefore, it will be tensile in the y direction, z direction. So it comes to plus mu times sigma x by E. And sigma y is tension in y direction. See, tension in y direction. Therefore, it should be compression in z direction. So lateral strain minus mu into sigma y by E. Now, once again, you substitute the values and simplify. You will get Ez. So Ex, Ey, Ez, they are all calculated using the generalized Hooke's law. So these three equations, they represent the generalized Hooke's law. So this one, Ex, Ey, Ez, they represent the generalized Hooke's law. Once you get these strains in the three directions separately, now if you add them, algebraically you add them. So Ex is negative, Ey is positive, Ez is positive. Just add them algebraically, considering the signs, you will get the volumetric strain. Because it is a rectangular bar, volumetric strain is given by Ex plus Ey plus Ez. When you add them, you are going to get this value, minus 2 into 10 power minus 5. So now we know that volumetric strain is equal to change in volume divided by initial volume, or change in volume is equal to volumetric strain multiplied by initial volume. So this is the volumetric strain, 2 into 10 minus 2 into 10 power minus 5. Initial volume is length into breadth into height. So 500 is the length, 200 is the breadth, 100 mm is the height. See this, 500 by 200 by 100. That is the initial volume. When you multiply these two, you will get the delta V value as 200 millimeter cube. So negative sign indicates that there is a decrease in volume. So finally, even though you have tensile force here, compressive force here, finally there will be a reduction in the volume of the bar. So we have to consider the total effect of all the forces on the bar. So even though two forces are tensile forces, one force is compressive force, final effect is there is a decrease in volume with a negative sign. That means it is decrease in volume. So there's a decrease in volume. That's what change in volume is negative. Change in volume is negative means it shows that there is a decrease in volume. So this is what one standard type of problem. Now next problem, see here in the next problem, there also we are using generalized Hooke's law. Let us see what is the unknown here. A 70 mm long block has a cross section of 50 mm by 10 mm. See, 70 mm long, 50 mm is this, 10 mm is this. Okay, rectangular bar. 70 by 50 by 10. The block is subjected to forces of 60 kilonewton tension. So 60 kilonewton tension on 50 mm by 10 mm. So 50 mm by 10 mm means, so this one, this is 50, this is 10, you know. So it is subjected to 60 kilonewton force, tensile force. So of course here figure is not given. In this problem, figure is not given. You have to draw the figure by noting the data. So draw a rectangular bar of dimensions 70 by 50 by 10. Now 50 by 10 area means this is 50, this is 10. You have a tensile force acting on it, 60 kilonewton. Of course, it will act both the sides. Here I have shown on only one side, but for equilibrium, this force should act like this also. Tensile force should act in the opposite direction here. So then only it will be in equilibrium. 60 kilonewton, it is acting on this tensile, and 110 kilonewton compression on 70 by 50 mm face. 70 by 50 means 70 by 50. So this is 70, this is 50. That means this face. On this face, you have a normal force of 110 kilonewton compression. It is compressive force towards the block. I have taken towards the block such that find the force P acting on 70 mm by 10 mm face. So this is 70 mm by 10 mm face, front face. 70 is this, 10 is this. So 70 mm by 10 mm face, unknown force is there. So this force we have to find out such that there is no change in volume. That means delta V is 0 here. He has given that delta V is equal to 0 or volumetric, there is no volumetric strain. You can write like that also, such that there is no volumetric strain or there is no change in volume. When delta V is 0, EV will be 0. So take E is equal to 200 GPa. GPa means gigapascal, that is 10 power 3 MPa. So 200 into 10 power 3 MPa or 2 into 10 power 5 MPa. So they are all same. So please make a note. GPa means 10 power 3 MPa. And mu as 0.3. He has given 0.3 here. Okay. So for steel, it can vary from 0.25 to 0.3. In this problem, Poisson's ratio is given as 0.3. Now, this is the diagram. So as per the details given in the problem, the diagram is drawn. So in x direction, 60 kN tension force is acting. Y direction, 110 kN force compression force is acting. Z direction, there is an unknown force P which we have to find out, such that there is no change in volume or there is no volumetric strain. So delta V is 0 or EV is equal to 0. Yes. Now in this problem, given delta V is 0, let P be let us assume that P has tensile force, because initially we will not be knowing what is the nature of that force, whether it is tensile or compression. We will assume it as tensile. If you get positive value, then P is tensile. If you get negative value for P, then it is compression. That's all. Okay. Now let us calculate the stresses as usual. So sigma x. Sigma x is the stress in x direction. Say force divided by area. 60 into 10 cube in newtons divided by 50 into 10. So that is the area over which this force is acting. If you simplify that, you will get 120 Newton per mm square. Next, sigma y. So this is tensile. Please make a note that in bracket you can write tensile. Next, sigma y is compression. It's a compressive force. 110 into 10 cube divided by 70 into 50. So that is the area. So you'll be getting 31.428 Newton per mm square compressive. You can write in brackets C. So this is T. T means tensile. C means compressive. Next, sigma Z, we have assumed P as tensile force. Therefore, this will be P divided by 70 into 10, which is unknown. We don't know the value of this. So P divided by 700, something like that you will get. So now, of course, if you write like this, P will be in kilonewtons. P is in kilonewtons. So this is unknown because P is the unknown thing. Now let us use the what is that generalized Hooke's law for this. So let us calculate Ex. Ex is the strain in x direction due to all these three stresses. So once again use the same concept. First one is the linear strain. Second and third terms are lateral strains. So linear strain, when you are writing, we have to take tensile for stress as positive, compressive stress as negative. When you are writing lateral strain, we have to consider particular opposite sense. For example, so here sigma x by E. So this is tensile, you know. So sigma x is tensile. This is 120 is tensile. So therefore it is positive. Sigma x divided by E gives the strain. Stress divided by Young's modulus, the linear strain. Now in y direction. So in y direction it is compressive. See here this is compressive. In that y direction it is compressive. Therefore in the x direction it becomes tensile. We are writing in x direction, you know. So y direction it is compressive. X direction it is tensile. Therefore you have to write plus here. Plus mu times we have to take into sigma y by E. So this you know how directly you can write. So only this plus or minus sign is very important. Next in z direction we have assumed in z direction P as tensile. Therefore a tensile stress will be there. In z direction it is tensile. In the other two directions it will be compressive. So that's why I have written in x. I am writing in x direction. You know. So minus mu times sigma z by E. Similarly, Ey is the strain in y direction due to all the three stresses. So first I will write sigma y in that direction. Sigma y by E will be there. Sigma y is compressive here. Compressive, therefore minus. I have taken minus sigma y by E. Next in x direction due to these two stresses. So in x direction it is tensile. Therefore I am writing in y direction it should be compressive. So minus mu times sigma x by E. Next in sigma z direction, sigma z is positive in z direction, that is tensile in z direction. Therefore it should be negative in the y direction. In the other two directions it will be negative. So minus I have taken. So minus mu times sigma z by E. Next similarly Ez is the strain in z direction due to all the three, sigma x, sigma y and sigma z. So first I will write sigma z by E. Since I have taken in z direction, tensile only. So linear strain will be positive, sigma z by tensile. Next, sigma x is tension in x direction. Therefore, it should be compression in y direction. Its effect will be compressive in z direction. So it is negative. So the effect of sigma x in z direction is negative. So minus mu times sigma x by e. Next, sigma y. Sigma y term. Sigma y is negative in y direction. Therefore, it should be positive in z direction. So plus mu times sigma y by e. So these are the directions over which we are writing the strains. Now, what you have to do is we want the volumetric strain. Volumetric strain is the sum of all these three strains, Ex plus Ey plus Ez. We know that it is 0 because as delta V is 0, EV is delta V by V, that is also 0. So volumetric strain in this problem, he has given it as 0. So put all these three, you add. You add all the three. So I have done it and equate it to 0 here. Equate it to 0. 1 by E you can take common. So 1 by E cannot be equated to 0. Therefore, you will be getting an equation of this kind. So substitute the value of mu here and the value of sigma x and sigma y also. Sigma z you can find out. So sigma z is the only unknown here. Find out sigma z, you are getting negative value. What is the meaning of that? So since sigma z is a negative value, it is compressive stress. But we have assumed initially sigma z as positive tensile because we don't know. We don't know what is the nature of that stress in z direction. P, whether it is tensile force or compressive force, we don't know. But assuming P as tensile, we have got negative value for sigma z here. That means in z direction, so the stress is negative, means it is compressive stress. Compressive stress. Once you know stress value, you can find out the force using the formula. Stress is equal to force divided by area. So that's what I have written here. P divided by 70 into 10. So if you substitute that as here sigma z as 88.57, negative sign indicates that it is compressive force. That's all. So 70 into 10 into 88.57, you will be getting in newtons. This value will be in newtons. Please make a note. This value will be in newtons. Divided by 1000, you will get in kilonewton. So the answer is minus 61.99 kilonewton. It is a compressive force. Why it is compressive force? You have got P value negative. Initially, we will not be knowing what is the value of what is the nature of that force P, whether it is a tensile force or a compressive force. After finding the value of P, if it is tensile, it is positive. If it is compressive, it becomes negative. So this is another type of problem. So wherein he has given there is no change in volume. Okay. So next problem, you see a steel bar of 300 mm by 50 mm by 12 mm. This is 300. This is 50. This is 12 mm. Is subjected to an axial along the length. Along the length, it is called as axis. Axis means if the force is acting along the axis of the bar, it is called as axial pull. Pull means tension. Push means compression. Please make a note of all these points. Pull means tension force. Push means compressive force. Okay, so 100 kilonewton is acting along the axis. That is pull means tension. 100 kilonewton. See the diagram. Determine the change in length, width, and thickness, and also delta V. Given mu is equal to 0.3, 0.32, of course, 0.32 I think he has given. E is equal to 200 GPa. E is equal to 200 GPa means 2 into 10 power 5 MPa. So in this problem, he has asked for change in the length, change in the width, change in the depth, as well as volumetric strain. Yes.
Sir, can you explain from first?
This problem,
Positive and negative.
this one, here. Which one you wanted? Generalized Hooke's law.
Sir, ಇದು ಕೆಳಗಿನ
ಯಾವ್ದಮ್ಮ ಇದಾ EXEYZ ಯಾವ್ದು ಬೇಕು ನಿಮಗೆ? This expression you want me to explain? ಇದಾ
ಸರ್ ಅದೇ ಇದೆ.
ಇದನ್ನ
ಸರ್
ಅದೇ
EX.
ಜನರಲ್ ಹೂಕ್ಸ್ ಲಾ ನೆನ್ನೆ
EX.
ಹೇಳದ್ನಲ್ಲ ಅದು. ಈಗ EX ಮೀನ್ಸ್ ಇಟ್ ಈಸ್ ದಿ ಸ್ಟ್ರೈನ್ ಇನ್ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್. ಆಯ್ತಾ? EX ಅಂದ್ರೆ ಸ್ಟ್ರೈನ್ ಇನ್ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಡ್ಯೂ ಟು ಆಲ್ ದಿ 3 ಸ್ಟ್ರೆಸಸ್. ಸಿಗ್ಮಾ ಎಕ್ಸ್, ಸಿಗ್ಮಾ ವೈ, ಸಿಗ್ಮಾ ಝೆಡ್ 3 ಇದೆ ಇದರಲ್ಲಿ ಅಲ್ವಾ? 3 ಇರುವಾಗ ಆ 3 ಎಫೆಕ್ಟ್ ಇರ್ತದೆ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ. ಅದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕು. ಸೊ ಅದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಫಸ್ಟ್ ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಟರ್ಮ್ ತಗೊಳ್ಳೋಣ. ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಎಷ್ಟಿದೆ? 120 ಇದೆ ಅಲ್ವಾ? ಅದು ಟೆನ್ಸೈಲ್ ಇದೆ. ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದು ಟೆನ್ಸೈಲ್ ಇದೆ. ಟೆನ್ಸೈಲ್ ಇದ್ದಾಗ ಪಾಸಿಟಿವ್ ತಗೊಳ್ಬೇಕು. ಆಯ್ತಾ? ಸೊ ಸ್ಟ್ರೈನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಸ್ಟ್ರೆಸ್ ಡಿವೈಡ್ ಬೈ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಆಸ್ ಪರ್ ಹೂಕ್ಸ್ ಲಾ. ಸೊ ಸ್ಟ್ರೆಸ್ ಡಿವೈಡ್ ಬೈ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಅನ್ನೋದು ಹೂಕ್ಸ್ ಲಾ, ಗೊತ್ತಾಯ್ತಾ? ಸೊ ಇದು 3 ಆಡ್ ಮಾಡೋದು ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಸೂಪರ್ ಪೊಸಿಷನ್. ಫಸ್ಟ್ ಟರ್ಮ್
ನೆಗೆಟಿವ್.
ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ. ಇದು ಮೊದಲನೇ ಪಾಸಿಟಿವ್ ಯಾಕೆ?
ಅದೇ ಸರ್ ಹೇಗ್ ತಗೊಳ್ಳೋದು ಅಂತ.
ಟೆನ್ಷನ್ ನ ಪಾಸಿಟಿವ್ ತಗೋಬೇಕು. ಟೆನ್ಷನ್ ಅಲ್ವಾ ಇದು? ಅವೇ ಫ್ರಮ್ ದಿ ಬಾರ್ ಅಲ್ವಾ ಇದು?
ಹಾ ಸರ್.
ಆರೋ ಹೀಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ, ಟೆನ್ಷನ್ ಇದು. ಆರೋ ಅವೇ ಫ್ರಮ್ ದಿ ಬಾರ್ ಇದ್ರೆ ಟೆನ್ಷನ್,
ಅವೇ ಇದ್ರೆ ಪಾಸಿಟಿವ್, ಇನ್ವರ್ಡ್ಸ್ ಇದ್ರೆ ನೆಗೆಟಿವ್. ಹಾ ಸರ್, ಓಕೆ ಸರ್.
ಕಂಪ್ರೆಷನ್ ಅದು.
ಹಾ
ಇದು
ಸರ್.
110 ಇದೆಯಲ್ಲ, ಇದು ಆರೋ ನೋಡಿ
ಹಾ
ಹೇಗಿದೆ?
ಹಾ.
ಪುಷ್
ಹಾ
ಇದು.
ಸರ್.
ಇದು ಪುಲ್, ಇದು ಪುಷ್. ಆಯ್ತಾ? ಪುಷ್ ಇದ್ದಾಗ ಏನಾಗ್ತದೆ, ನೆಗೆಟಿವ್ ಆಗಿ ತಗೋಬೇಕಂದ್ರೆ ಆ ಡೈರೆಕ್ಷನ್ ಡಿಫಾರ್ಮೇಶನ್ ಕಡಿಮೆ ಆಗುತ್ತಲ್ಲ, ಬಿಡ್ತ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಇದು ಲೆಂತ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ, ಬ್ರೆಡ್ತ್ ಮತ್ತೆ ಡೆಪ್ತ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. ಹಾಗೆ ಅರ್ಥ ಆಯ್ತಾ? ಈಗ ಇಲ್ಲಿ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ 60 ಕಿಲೋಮೀಟರ್ ಟೆನ್ಷನ್. ಟೆನ್ಷನ್ ಇದ್ದಾಗ ಪಾಸಿಟಿವ್. ಈಗ ಅರ್ಥ ಆಯ್ತಾ? ಪ್ಲಸ್ ಈಗ ಸಿಗ್ಮಾ ವೈ ನೋಡಿ. ನೆಕ್ಸ್ಟ್ ಸಿಗ್ಮಾ ವೈ. ಸಿಗ್ಮಾ ವೈ ವೈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ನೆಗೆಟಿವ್ ಇದೆ, ಹೌದಾ? ಯಾಕೆ ನೆಗೆಟಿವ್? ವೈ ಡೈರೆಕ್ಷನ್ ನೆಗೆಟಿವ್ ಯಾಕೆಂದ್ರೆ ಇದು ಕಂಪ್ರೆಷನ್. ಇದು ವೈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಕಂಪ್ರೆಷನ್ ನೋಡಿ. ಇದು ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್, ಇದು ವೈ ಡೈರೆಕ್ಷನ್, ಇದು ಝೆಡ್ ಡೈರೆಕ್ಷನ್. ಈಗ ಝೆಡ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಫೋರ್ಸ್ ಅನ್ನೋನ್ ಇದೆ ಇಲ್ಲಿ ಅಷ್ಟೇ, ಅದನ್ನ ಕಂಡುಹಿಡಿಬೇಕು ನಾವು. ಸೊ ನಾವು ಹಿಯರ್ ವೈ ಡೈರೆಕ್ಷನ್ 110 ಕಿಲೋಮೀಟರ್ ಇಸ್ ಕಂಪ್ರೆಷನ್. ಕಂಪ್ರೆಷನ್ ಅಂತ ಕೊಟ್ಟಾಗ ವೈ ಡೈರೆಕ್ಷನ್ ನೆಗೆಟಿವ್ ಆಗ್ತದೆ, ಬಟ್ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಏನಾಗ್ತದೆ, ಅದು ಪಾಸಿಟಿವ್ ಆಗ್ತದೆ. ಅದನ್ನ ಹೇಳ, ಅದಕ್ಕೆ ಪ್ಲಸ್ ಬರ್ತಿದ್ದೀನಿ. ಈಗ ಅರ್ಥ ಆಯ್ತಾ? ನೀವು ಪ್ರತಿಯೊಂದರಲ್ಲೂ ಪ್ರತಿಯೊಂದು ಟರ್ಮ್ನಲ್ಲೂ ಸಿಗ್ಮಾ ಎಕ್ಸ್, ಸಿಗ್ಮಾ ವೈ, ಸಿಗ್ಮಾ ಝೆಡ್ 3 ಟರ್ಮ್ ಇರುತ್ತೆ. ಡಿವೈಡೆಡ್ ಬೈ ಇ ಕೂಡ ಇರುತ್ತೆ ನೋಡಿ, ಕಾಮನ್ ಅದು. ಸಿಗ್ಮಾ ಎಕ್ಸ್, ಸಿಗ್ಮಾ ವೈ, ಸಿಗ್ಮಾ ಝೆಡ್ 3 ಇರುತ್ತೆ, ಡಿವೈಡ್ ಬೈ ಇ ಇರುತ್ತೆ. ದಟ್ ಇಸ್ ಬೈ ಹೂಕ್ಸ್ ಲಾ. ಮ್ಯೂ ಯಾಕೆ ಬರುತ್ತೆ? ಬರ್ತದೆ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್, ಅದು ಪಾಸಿಟಿವ್ ಆಗ್ತದೆ, ಅದರಿಂದ ಅದು ಪ್ಲಸ್ ಆಗ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಸಿಗ್ಮಾ ಝೆಡ್ ನೋಡಿ. ಸಿಗ್ಮಾ ಝೆಡ್ ಟೆನ್ಷನ್ ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ ನಾನು. ಟೆನ್ಷನ್ ಅಂತ ತಕೊಂಡ್ರೆ ಪಾಸಿಟಿವ್, ಅದು ಝೆಡ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಪಾಸಿಟಿವ್, ಬಟ್ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಾ ಈಗ?
ಹಾ ಸರ್.
ನೀವು ಒಂದೆರಡು ಮೂರು ಪ್ರಾಬ್ಲಮ್ ನೋಡಿ ಗೊತ್ತಾಗ್ತದೆ. ಪ್ಲಸ್ ಮೈನಸ್ ಬರೆಯೋದನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ಕಲ್ತ್ಕೊಳ್ಳಿ. ನೋಡಿ ಇ ವೈ ಹೇಳ್ತೀನಿ ನೆಕ್ಸ್ಟ್. ಇ ವೈ ನಲ್ಲಿ ನೋಡಿ, ಇ ವೈ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ದಿ ಸ್ಟ್ರೈನ್ ಇನ್ ವೈ ಡೈರೆಕ್ಷನ್. ಸ್ಟ್ರೈನ್ ಇನ್ ವೈ ಡೈರೆಕ್ಷನ್ ಡ್ಯೂ ಟು ಸಿಗ್ಮಾ ವೈ ನೆಗೆಟಿವ್. ಫಸ್ಟ್ ಬರ್ತಿದ್ದೀನಿ ನೆಗೆಟಿವ್, ಯಾಕಂದ್ರೆ ಕಂಪ್ರೆಷನ್ ಅದು. ಡ್ಯೂ ಟು ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಏನಾಗುತ್ತೆ? ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಪಾಸಿಟಿವ್ ಆದ್ರೆ ವೈ ಡೈರೆಕ್ಷನ್ ಏನಾಗುತ್ತೆ?
ನೆಗೆಟಿವ್.
ಮತ್ತೆ ಸಿಗ್ಮಾ ಝೆಡ್ ಝೆಡ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಪಾಸಿಟಿವ್, ಟೆನ್ಷನ್ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಲ್ಲ, ವೈ ಡೈರೆಕ್ಷನ್ ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ, ಅದಕ್ಕೆ ಮೈನಸ್. ಅರ್ಥ ಆಯ್ತಾ? ಹೀಗೆ ಲೈಕ್ ದಟ್ ವಿ ಹ್ಯಾವ್ ಟು ರೈಟ್. ಈಗ ಈ ಪ್ರಾಬ್ಲಮ್ ನೋಡುವ. ಇಲ್ಲಿ 300/50/12 ಇದೆ. 100 ಕಿಲೋನ್ಯೂಟನ್ ಫೋರ್ಸ್ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಮಾತ್ರ ಕೊಟ್ಟಿದ್ದಾರೆ, ಬೇರೆ ಏನ್ ಕೊಟ್ಟಿಲ್ಲ ಇಲ್ಲಿ. ಬರೀ ಒಂದೇ ಫೋರ್ಸ್ ಕೊಟ್ಟಿರೋದಿಲ್ಲ. ಅರ್ಥ ಆಯ್ತಾ? ಹಿ ಹ್ಯಾಸ್ ಗಿವನ್ ದಿ ಫೋರ್ಸ್ ಇನ್ ಓನ್ಲಿ ಒನ್ ಡೈರೆಕ್ಷನ್. ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಮಾತ್ರ ಫೋರ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಏನ್ ಕೇಳಿದ್ದಾರೆ ಇಲ್ಲಿ? ಡಿಟರ್ಮಿನ್ ದಿ ಚೇಂಜ್ ಇನ್ ಲೆಂತ್, ವಿಡ್ತ್ ಅಂಡ್ ಥಿಕ್ನೆಸ್. ಅಂದ್ರೆ ಡೆಲ್ಟಾ ಎಕ್ಸ್, ಡೆಲ್ಟಾ ವೈ, ಡೆಲ್ಟಾ ಝೆಡ್. ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಇಸ್ ದಿ ಚೇಂಜ್ ಇನ್ ಲೆಂತ್. ಡ್ಯೂ ಟು ದಿಸ್ ಫೋರ್ಸ್ ಏನಾಗ್ತದೆ, ಇದು ಲೆಂತ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ, ಇದು ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ, ಥಿಕ್ನೆಸ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. ನೋಡಿ ಈ ಪ್ರಾಬ್ಲಮ್ ಗೊತ್ತಾಗುತ್ತದೆ. ಈಗ ಇದು ಫೋರ್ಸ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ವಾ? ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಹೆಂಗ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಾ? ಫೋರ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಏರಿಯಾ. ಸೊ ಯಾವ ಏರಿಯಾ ತಗೋಬೇಕು? ವಿಚ್ ಏರಿಯಾ ಟೇಕ್ 50 into 12 ಇದನ್ನ ತಗೊಳ್ಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ 100 kilonewton is acting over this area. 50 into 10 perpendicular to the force, that is cross sectional area we have to take. So 100 into 10 cube in Newton divided by 50 into 12. So Newton per mm square. ಇದೇನಾಗುತ್ತೆ? ಇದು ಟೆನ್ಷನ್ ಏನು? ಟೆನ್ಸೈಲ್ ಫೋರ್ಸ್ ಇದು, ಟೆನ್ಸೈಲ್ ಸ್ಟ್ರೆಸ್ ಇದು. ಓಕೆ, ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಟೆನ್ಸೈಲ್. ಸಿಗ್ಮಾ ವೈ ಇಲ್ಲ ಇಲ್ಲಿ. ಯಾಕೆ ಸಿಗ್ಮಾ ವೈ ಇಲ್ಲ? ದೇರ್ ಇಸ್ ನೋ ಫೋರ್ಸ್ ಗಿವನ್ ಇನ್ ವೈ ಡೈರೆಕ್ಷನ್. ಝೀರೋ ಫೋರ್ಸ್ ಇಲ್ಲ. ಅದರಿಂದ ಸಿಗ್ಮಾ ವೈ 0 ಆಗ್ತದೆ. ಸಿಗ್ಮಾ ಝೆಡ್ ಕೂಡ 0, ಯಾಕೆ ದೇರ್ ಇಸ್ ನೋ ಫೋರ್ಸ್ ಇನ್ ಝೆಡ್ ಡೈರೆಕ್ಷನ್. ಸಿಗ್ಮಾ ಝೆಡ್ ಈಸ್ ಆಲ್ಸೋ 0. ಈಗ ನೋಡಿ, ಇಲ್ಲಿ ಸಿಗ್ಮಾ ಎಕ್ಸ್, ಸಿಗ್ಮಾ ವೈ, ಸಿಗ್ಮಾ ಝೆಡ್ ಎರಡು 0 ಆಗಿರೋದ್ರಿಂದ ಇ ಎಕ್ಸ್ ಏನಾಗ್ತದೆ? ಇ ಎಕ್ಸ್ ಬರೀ ಒಂದೇ ಟರ್ಮ್, ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಬೈ ಇ ಬರ್ತದೆ. ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಬೈ ಅಂದ್ರೆ ಯಾಕೆ? ಅದು ಪಾಸಿಟಿವ್ ಅಲ್ವಾ, ಟೆನ್ಷನ್ ಅದು, ಅದರಿಂದ ಪ್ಲಸ್ ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ. ಸೊ ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಇಸ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ. ಈ ವ್ಯಾಲ್ಯೂ 2 × 10⁵ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ದಿಸ್ ಈಸ್ ದಿ ಸ್ಟ್ರೈನ್ ಇನ್ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್. ನೆಕ್ಸ್ಟ್ ಸ್ಟ್ರೈನ್ ಇನ್ ವೈ ಡೈರೆಕ್ಷನ್ ಏನಾಗುತ್ತೆ ಹೇಳಿ? ಸ್ಟ್ರೈನ್ ಇನ್ ವೈ ಡೈರೆಕ್ಷನ್ ಸಿಗ್ಮಾ ವೈ ಇಲ್ಲ ಇಲ್ಲಿ, ಅದರಿಂದ ಆ ಟರ್ಮ್ ಬರಲ್ಲ. ನೋಡಿ, ಈ ಟರ್ಮ್ ಬರಲ್ಲ, ಫಸ್ಟ್ ಟರ್ಮ್ ಬರೋದಿಲ್ಲ, ಈ ಟರ್ಮ್ ಇಲ್ಲ, ಝೆಡ್ ಟರ್ಮು ಇಲ್ಲ, ಇಲ್ಲಿ ಎಕ್ಸ್ ಮಾತ್ರ, ಈ ಟರ್ಮ್ಸ್ ಮಾತ್ರ ಇರ್ತದೆ. ಎಕ್ಸ್ ಡ್ಯೂ ಟು ಎಕ್ಸ್ ಏನಾಗ್ತದೆ? ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಟೆನ್ಸೈಲ್ ಸ್ಟ್ರೆಸ್ ಇದೆ, ಅದು ಪಾಸಿಟಿವ್, ದೇರ್ ಫಾರ್ ವೈ ಡೈರೆಕ್ಷನ್ ನೆಗೆಟಿವ್ ಆಗ್ತದೆ. ಸೊ ಮೈನಸ್ ತಗೊಂಡಿದ್ದೀನಿ, ಮೈನಸ್ ಮ್ಯೂ ಟೈಮ್ಸ್ ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಬೈ ತಗೋಬೇಕು, ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಇಷ್ಟು ಬರ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಇ ಝೆಡ್ ಅಂದ್ರೆ ದಟ್ ಈಸ್ ಸ್ಟ್ರೈನ್ ಇನ್ ಝೆಡ್ ಡೈರೆಕ್ಷನ್ ಡ್ಯೂ ಟು ಸಿಗ್ಮಾ ಎಕ್ಸ್. ಸೊ ಅಲ್ಲೇನಾಗ್ತದೆ? ಅಲ್ಲೂ ಅಷ್ಟೇನೆ, ಇದು ನೆಗೆಟಿವ್ ಇರೋದ್ರಿಂದ, ಇದು ಪಾಸಿಟಿವ್ ಇರೋದ್ರಿಂದ, ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಸ್ಟ್ರೆಸ್ ಪಾಸಿಟಿವ್ ಇರೋದ್ರಿಂದ ವೈ ಅಂಡ್ ಝೆಡ್ ಡೈರೆಕ್ಷನ್ ನೆಗೆಟಿವ್ ಇರ್ತದೆ. ಸೊ ಮೈನಸ್ ಬರ್ತದೆ ಅಲ್ಲೂ ಕೂಡ. ನೋಡಿ, ಇದೆರಡು ಮೈನಸ್, ಇದು ಪ್ಲಸ್, ಮ್ಯೂ ಹಾಗೆ ಇರ್ತದೆ. ಸೊ ಇದು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. ಈಗ ಏನಾಗುತ್ತೆ? ನಾವು ಟೋಟಲ್ ವಾಲ್ಯೂಮೆಟ್ರಿಕ್ ಸ್ಟ್ರೈನ್ ಏನೋ 3 ಆಡ್ ಮಾಡಬೇಕು, ಇ ಎಕ್ಸ್ ಪ್ಲಸ್ ಇ ವೈ ಪ್ಲಸ್ ಇ ಝೆಡ್, ಇದು 3 ಆಡ್ ಮಾಡಿ. ಇದು 8.33 ಮೈನಸ್ 2.666 ಮೈನಸ್ 2.66 ಅಂದ್ರೆ 3 × 10⁻⁴ ಆಗುತ್ತೆ. ಈ ಚಿಹ್ನೆ ತಗೋಬೇಕು, ಚಿಹ್ನೆ ಸೈನ್ ಇಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ನೆಕ್ಸ್ಟ್ ಏನಾಗುತ್ತೆ? ಸೊ ಡೆಲ್ಟಾ ವಿ ಈಸ್ ಚೇಂಜ್ ಇನ್ ವಾಲ್ಯೂಮ್. ಚೇಂಜ್ ಇನ್ ವಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ? ಈಗ ಈ ವಾಲ್ಯೂಮೆಟ್ರಿಕ್ ಸ್ಟ್ರೈನ್ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ ಇನಿಷಿಯಲ್ ವಾಲ್ಯೂಮ್ 300 × 50 × 12, ಅದನ್ನ ಮಾಡಿದಾಗ ನಿಮಗೆ ಚೇಂಜ್ ಇನ್ ವಾಲ್ಯೂಮ್ 54 mm³ ಬರುತ್ತೆ. ಈಗ ಈ 54 mm³ ಇದೆಯಲ್ಲ, ಇದು ಇನ್ಕ್ರೀಸ್ ಇನ್ ವಾಲ್ಯೂಮ್. ಯಾಕೆ ಇನ್ಕ್ರೀಸ್ ಇನ್ ವಾಲ್ಯೂಮ್? ಬಿಕಾಸ್ ಯು ಹ್ಯಾವ್ ಗಾಟ್ ಇ ವಿ ಪಾಸಿಟಿವ್ ಅಲ್ವಾ, ಇ ವಿ ಪಾಸಿಟಿವ್. ಸಿನ್ಸ್ ಯು ಹ್ಯಾವ್ ಗಾಟ್ ವಾಲ್ಯೂಮೆಟ್ರಿಕ್ ಸ್ಟ್ರೈನ್ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ, ಇಟ್ ಇಸ್ ಇನ್ಕ್ರೀಸ್ ಇನ್ ವಾಲ್ಯೂಮ್. ಇಫ್ ಯು ಗೆಟ್ ಇ ವಿ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ, ಇಟ್ ಇಸ್ ಡಿಕ್ರೀಸ್ ಇನ್ ವಾಲ್ಯೂಮ್. ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ನಲ್ಲಿ ನೋಡಿ, ಲಾಸ್ಟ್ ಯಾವ್ದೋ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ನಲ್ಲಿ ಇ ವಿ ನೋಡಿ, ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಅಂತಲ್ಲ, ಫಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ನಲ್ಲಿ ನೆಗೆಟಿವ್. ಇಫ್ ಯು ಗೆಟ್ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ, ಇಟ್ ಇಸ್ ಡಿಕ್ರೀಸ್ ಇನ್ ವಾಲ್ಯೂಮ್. ಸೊ ಇಫ್ ಯು ಗೆಟ್ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ, ಇಟ್ ಇಸ್ ಇನ್ಕ್ರೀಸ್ ಇನ್ ವಾಲ್ಯೂಮ್. ನೆಕ್ಸ್ಟ್ ಏನ್ ಕೇಳಿದಾನೆ? ಇಷ್ಟೇ ಕೇಳಿಲ್ಲ. ನೆಕ್ಸ್ಟ್ ಏನ್, ವಾಟ್ ಹ್ಯಾಸ್ ಆಸ್ಕ್ಡ್, ವಾಟ್ ಇಸ್ ದಿ ಚೇಂಜ್ ಇನ್ ಲೆಂತ್, ವಿಡ್ತ್ ಅಂಡ್ ಥಿಕ್ನೆಸ್. ನೋಡಿ, ಚೇಂಜ್ ಇನ್ ಲೆಂತ್, ವಿಡ್ತ್ ಅಂಡ್ ಥಿಕ್ನೆಸ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಸಿಂಪಲ್ ಫಾರ್ಮುಲಾ ಇದು. ಏನ್ ಫಾರ್ಮುಲಾ? ಇ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಬೈ ಎಕ್ಸ್. ಅಂದ್ರೆ ಸ್ಟ್ರೈನ್ ಇನ್ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಡಿಫಾರ್ಮೇಶನ್ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಡಿವೈಡ್ ಬೈ ಡೈಮೆನ್ಷನ್ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್. ಸೊ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಬೈ ಎಕ್ಸ್ ಇಸ್ ಇ ಎಕ್ಸ್, ಅದನ್ನ ಯೂಸ್ ಮಾಡಬೇಕು. ಅಂದ್ರೆ ಇಲ್ಲಿ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಇ ಎಕ್ಸ್ ಇಂಟು ಎಕ್ಸ್ ಆಗುತ್ತೆ. ಸೊ ಇ ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿದೆ ನಿಮ್ಗೆ, ಕಂಡುಹಿಡಿದಿದ್ದೀರಲ್ಲ. ಸೊ ಯು ಹ್ಯಾವ್ ಗಾಟ್ ದಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಇ ಎಕ್ಸ್. ಇ ಎಕ್ಸ್ ಇಸ್ 8.33 × 10⁻⁴ ಇಂಟು ಎಕ್ಸ್ ಅಂದ್ರೆ ಇನಿಷಿಯಲ್ ಲೆಂತ್ ಇನ್ ದಿ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ 300 mm. ಎಕ್ಸ್ ಹಿಯರ್ ಇಸ್ 300, ವೈ 50, ಝೆಡ್ 12 mm. ಆಯ್ತಾ? ಆ ತರ ತಗೋಬೇಕು, ಎಕ್ಸ್ ವೈ ಝೆಡ್ ಅಂತ ತಗೊಳ್ಬೇಕು. ಸಿಮಿಲರ್ಲಿ ಡೆಲ್ಟಾ ವೈ ಇಸ್ ಈಕ್ವಲ್ ಟು, ನೋಡಿ ನೆಕ್ಸ್ಟ್ ಫಾರ್ಮುಲಾ ಏನ್ ಗೊತ್ತಾ? ಇ ವೈ, ಇಲ್ಲಿ ಫಾರ್ಮುಲಾ ಬಿಟ್ಬಿಟ್ಟಿದ್ದೀನಿ ಅಷ್ಟೇ, ಅದನ್ನ ಬರ್ಕೊಳ್ಳಿ. ಇ ವೈ ಇಸ್ ಈಕ್ವಲ್ ಟು ಡೆಲ್ಟಾ ವೈ ಬೈ ವೈ ಆಗುತ್ತೆ, ಡೆಲ್ಟಾ ವೈ ಬೈ ವೈ. ಸೊ ಆಗ ಡೆಲ್ಟಾ ವೈ ಇಸ್ ಈಕ್ವಲ್ ಟು ಇ ವೈ ಇಂಟು ವೈ ಆಗುತ್ತೆ. ಸೊ ಯು ನೋ ದಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಇ ವೈ ಹಿಯರ್, ಇ ವೈ ನೆಗೆಟಿವ್ ಇಷ್ಟಿದೆ, ಇಂಟು ವೈ ವ್ಯಾಲ್ಯೂ ಇಸ್ 50 mm. ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಬರುತ್ತೆ. ನೆಗೆಟಿವ್ ಅಂದ್ರೆ ಏನಂತ? ದೇರ್ ಇಸ್ ಎ ಡಿಕ್ರೀಸ್ ಇನ್ ವಿಡ್ತ್ ಅಂತ, ಅರ್ಥ ಆಯ್ತಾ? ವಿಡ್ತ್ ರೆಡ್ಯೂಸ್ ಆಗ್ತದೆ, ಲೆಂತ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ಬಿಕಾಸ್ ದೇರ್ ಇಸ್ ಎ ಟೆನ್ಷನ್ ಫೋರ್ಸ್ ಇನ್ ಲೆಂತ್ ಡೈರೆಕ್ಷನ್, it will elongate. So delta x is positive, delta y is negative, delta z is also negative. ನೋಡಿ ಅದು ತೋರಿಸೋದು ಡೆಲ್ಟಾ z. ಡೆಲ್ಟಾ z ಬೇಕಾದ್ರೆ we know that Ez is equal to delta z by z. ಆ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಬೇಕು. ಆಗ ಡೆಲ್ಟಾ z is equal to Ez into z ಆಗುತ್ತೆ, ನೆಗೆಟಿವ್ ಬರ್ತದೆ. ಸೊ ಇಲ್ಲಿ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ನೀವು ಬರ್ಕೊಳ್ಬೇಕು. ಏನ್ ಬರ್ಕೊಳ್ಬೇಕು? ಮೊದಲನೇದು ಎಲಾಂಗೇಷನ್, ಎಕ್ಸ್ಟೆನ್ಷನ್ ಅಥವಾ ಎಲಾಂಗೇಷನ್. ಸೊ ಲೆಂತ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್, ಲೆಂತ್ ಆಫ್ ದಿ ಬಾರ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್ ಬೈ ದಿಸ್ ಮಚ್. Width of the bar will reduce by this much. Minus ಅಂದ್ರೆ reduction in the width. ಇದು reduction in depth. ಇಷ್ಟು reduce ಆಗ್ತದೆ. Very small quantities ಅದು. 0.001 ಆ ತರ ಬರುತ್ತೆ millimeters. So this is how we have to find out the, if they ask you the change in length, width and depth, you have to do like this. So I explained you 3 problems today, generalized Hooke's law. So you can solve some more problems. So from the textbook. Anyway, I will send you some problems for solving. You can try on similar lines. So or one of from Punmya book or Bhavikatti book is there, Basavaraja Mahadevappa book is there. They are all good books, strength of materials. So soft copy, I think you can get it in the internet. Otherwise, I have to send you. So this is my notes written. So this I am explaining. Almost all the types of problems I am covering here. Only thing is you should be careful about some notations which are used in the textbooks. If you are seeing the textbook, be careful about the notations. That's all. So today, what we did, I explained you about the how to calculate the volumetric strain in a cylindrical ball. Okay, which is given by this formula, delta L by L, that is your linear strain, plus 2 times the diametrical strain. So that is the derivation. For a sphere, it is 3 times the diametrical strain. Next, problems on generalized Hooke's law. So you have to practice this. So some 3-4 problems you practice of this kind. So it will be easy for you to analyze any type of problem. So the thing is, when you are taking generalized Hooke's law, when you are writing generalized Hooke's law, when you are writing the expression for strains, in that direction, particular direction, it is linear strain. In the other 2 directions, it is lateral strain. In the lateral strain term, mu term will come, and you have to decide whether it is plus or minus depending on the effect. For example, in x direction, if it is tensile, strain is positive in x direction, but due to that, it will be negative in the other 2 directions, y and z directions. So like that concept, you have to keep it in mind. And some 2-3 types of problems I have done. One, finding the change in volume, another one, finding the unknown force itself, and the third problem, change in length, width, and thickness. So 3 types of problems I have covered. So in the next class, we will move on to what is called as simple shear or pure shear, and then I have to take up elastic constants, and derivations are there, some 2-3 derivations are there in that. Then I have to go for temperature stresses. So there, if I complete the temperature stresses, then only this chapter is over. So first module is a very lengthy module. Okay, so for your first test, all these will be there. So I have to complete this, and then I have to start little bit of second module also for the test. I think first test is fixed on 5th, 6th, 7th of October, it seems. So we have to do that. So till that, all of you have to practice all these problems, whatever I have explained in the class, and I am going to give you another set of problems. You try to solve those problems with solution, of course. With solution, some answers will be there. You have to check that, you can consider as an assignment. So each module will have assignments also. Some weightage will be there for that also. Okay. So only when you start practicing all these problems and derivations, then only you will be having doubts. Otherwise, you will not be having any doubts at all. So people can have doubts, don't have doubts in 2 cases. 2 ಕೇಸಲ್ಲಿ ಡೌಟ್ ಬರುವುದಿಲ್ಲ. 1 ಕೇಸ್ ಎಲ್ಲ ಅರ್ಥ ಆಗಿದ್ರೆ ಡೌಟ್ ಬರುವುದಿಲ್ಲ. ಸೆಕೆಂಡ್ ಕೇಸ್ ಏನು ಅರ್ಥ ಆಗಿಲ್ಲದೆ ಇರೋ ಡೌಟ್ ಬರುವುದಿಲ್ಲ. ಅರ್ಥ ಆಯ್ತಾ? ಹಾಗಾಗಿ ಯು ಹ್ಯಾವ್ ಟು ವರ್ಕ್. So as I already told from the beginning itself, so strength of materials as well as fluid mechanics, you should work. Unless you work, it is very difficult to understand the fundamental concepts of these subjects. Okay. Any doubt is there? Next class,
No,
I will be doing this. Thirteen 12 students are there. Okay, 1 second. $19,002.
Yes, sir.
005.
Present.
006.
Present, sir.
007.
Present, sir.
011.
Present, sir.
013.
Present, sir.
014. 015. 016. 017. 018. 019. 020. 021. 022. 023. 024. 025. 026. 027. 028. 029. 030. 031. 032. 033. 034. 035. 036. 037. 038. 039. 040. 041. 042. 043. 044. 045. 046. 047. 048. 049. 050. 051. 052. 053. 054. 055. 056. 057. 058. 059. 060. 061. 062. 063. 064. 065. 066. 067. 068. 069. 070. 071. 072. 073. 074. 075. 076. 077. 078. 079. 080. 081. 082. 083. 084. 085. 086. 087. 088. 089. 090. 091. 092. 093. 094. 095. 096. 097. 098. 099. Then 016.
Present, sir.
017.
Present, sir.
018. 018. 018. ಮಲ್ಕೊಂಬಿಟ್ಟಿದಾನ?
Present, sir. Present, sir.
ಹಾ, ಎಲ್ಲಿ ಏನ್ ಮಾಡ್ತಿದ್ದೆ ಮರೆಯ? 019.
Present, sir.
021.
Yes, sir.
ಅಷ್ಟೇ ಜನ. ಇನ್ಯಾರು ಇದ್ದಾರೆ ಮಿಸ್ ಆಗಿರೋದು? ಯಾರಿಲ್ಲ.
ಸರ್
Okay.
00 ಹೇಳಿಲ್ಲ.
009 ಹೇಳ್ದೆ. 009 ಹೇಳಾಯ್ತು. ನಿಶಾಂತ್ ಅಲ್ವಾ?
ಸರ್
ಹಾ, ಓಕೆ ಓಕೆ, ವಿಲ್ ಮೀಟ್ ಇನ್ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್. ಎಲ್ಲ ವರ್ಕ್ ಮಾಡ್ತಾ ಇರಿ, ಯಾಕೆಂದ್ರೆ ನೀವು ಕಾಲೇಜ್ ಯಾವಾಗ ಬರ್ತಿರೋ ಗೊತ್ತಿಲ್ಲ. ಟೆಸ್ಟ್ ಮಾತ್ರ ಆನ್ಲೈನ್ ಇರ್ತದ ಅವಾಗ. ಹೇಳಿ
ಸರ್, ಅಸೈನ್ಮೆಂಟ್ ಕ್ವಶನ್ಸ್ ಕೊಡ್ತೀರಾ?
ಹಾ, ಕೊಡ್ತೀನಿ. ಅಸೈನ್ಮೆಂಟ್ ಕೊಡ್ಲೇಬೇಕಲ್ಲಮ್ಮ, ಕೊಡ್ಲೇಬೇಕು. ಅಸೈನ್ಮೆಂಟ್ ಕೊಡ್ತೀನಿ. ಮಾಡ್ಯೂಲ್ 1 ಅಸೈನ್ಮೆಂಟ್ ಇರ್ತದೆ ನಿಮ್ಗೆ, ಆಯ್ತಾ? ಮಾಡ್ಯೂಲ್ 1 ಕಂಪ್ಲೀಟ್ ಆದ ತಕ್ಷಣ ಒಂದು ಅಸೈನ್ಮೆಂಟ್ ಕೊಡ್ತೇನೆ ನಿಮ್ಗೆ. ಮತ್ತೆ ಇದೆಲ್ಲ ಈಗ
Yes,
ನಾವು
sir.
ಏನ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ನಿಮ್ಗೆ ಮಾಡಿಸಿದೀನಿ, ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದೀನಿ. ಆಲ್ ಆಫ್ ಯು ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಕನ್ನಡನ? ಯಾರಾದ್ರೂ ಕನ್ನಡ ಬರದೇ ಇರೋರು ಇದ್ದಾರಾ? ಎನಿಬಡಿ ಡಸಂಟ್ ನೋ ಕನ್ನಡ?
Kashmiri peoples.
ಯಾರು ಜಾಯಿನ್ ಆಗಿಲ್ವಲ್ಲ ಇದು? ಕಾಶ್ಮೀರದವ್ರು ಯಾರಿದ್ದಾರೆ? ಯಾರಿಲ್ಲ ಕಾಶ್ಮೀರದವ್ರು. Who is
ಮೂವರಿದ್ದಾರೆ
Kashmir?
ಸರ್, ಜಾಯಿನ್ ಆಗಿಲ್ಲ.
ಜಾಯಿನ್ ಆಗಿಲ್ಲ. ಅದೇ ಅವ್ರು ಜಾಯಿನ್ ಆಗಿಲ್ಲ. ಪಾಪ ಅವ್ರಿಗಿಲ್ಲ. ಹಾಗಾಗಿ ಅವರಿದ್ದಾಗ ಕನ್ನಡದಲ್ಲಿ ಮಾತಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ, ಕಷ್ಟ ಆಗ್ತದೆ. ಕಾಶ್ಮೀರ ಲ್ಯಾಂಗ್ವೇಜ್ ನನಗೆ ಬರೋದಿಲ್ಲ ಅಲ್ಲ. ಓಕೆ, ನೀವು ನಾನು ಏನೇನು ಪ್ರಾಬ್ಲಮ್ಸ್ ಈಗ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದೀನಿ ನೋಟ್ಸ್ ಅಲ್ಲಿ, ಅದನ್ನೇ ನೀವು ನೋಟ್ಸ್ ತರ ಬರ್ಕೋಬೇಕು, ಗೊತ್ತಾಯ್ತಾ? ಅಲ್ಲಿ ನಾನೆಲ್ಲ ಸ್ಟೆಪ್ಸ್ ಎಲ್ಲ
Yes, sir.
ಕೆಲವೆಲ್ಲ ಇರೋದಿಲ್ಲ, ಅದನ್ನೇ ವರ್ಕೌಟ್ ಮಾಡಿ ನಿಮ್ಗೆ ಏನೇ ಇರಿದ್ರು ಕೇಳಿ. ನಿಮ್ಗೆ ಈ ಕ್ಲಾಸ್ ಟೈಮ್ ಅಲ್ಲೇ ಕೇಳಬೇಕು ಅಂತ ಏನಿಲ್ಲ, ಯಾಕಂದ್ರೆ ನಿಮ್ಗೆ ಶಾರ್ಟೇಜ್ ಆಗ್ಬೋದು ಟೈಮ್. ಫೋನ್ ನಂಬರ್ ಇದೆಯಾ ನಂದು ನಿಮ್ಮ ಹತ್ರ?
ಗ್ರೂಪ್ ಅಲ್ಲಿ ತಗೋತೀನಿ.
ಗ್ರೂಪ್ ಅಲ್ಲಿ ಇದೆಯಲ್ಲ, ವಾಟ್ಸಪ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಇದೆಯಲ್ಲ, ನೀವು ಕಾಲ್ ಮಾಡಿ, ಆಯ್ತಾ? ತೊಂದ್ರೆ ಇಲ್ಲ. ನೀವು ಫ್ರೀ ಟೈಮ್ ನಲ್ಲಿ ಯಾವಾಗಲಾದ್ರೂ ನಾನು ಫ್ರೀ ಇದ್ರೆ ನಾನು ಹೇಳ್ಕೊಡ್ತೇನೆ, ಆಯ್ತಾ? ನೀವು ಕಾಲೇಜಿಗೆ ಬರೋ ತನಕ ಆ ಥರನೇ ಮಾಡಬೇಕು. ಒನ್ಸ್ ಯು ಸ್ಟಾರ್ಟ್ ಕಮಿಂಗ್ ಟು ಕಾಲೇಜ್ ದೇರ್ ಇಸ್ ನೋ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, ಹ್ಯಾವ್ ಗುಡ್ ಲಂಚ್, ಪ್ರಿಪೇರ್ ಫಾರ್ ದಿ ಆಫ್ಟರ್ನೂನ್ ಕ್ಲಾಸ್, ಡೋಂಟ್ ಸ್ಲೀಪ್ ಆಫ್.